viewers. This is Afia Ademola Johnson, your science tutor. In another series of a periodic table, we want to look at metals, classification of elements into metals. Metals. What are metals? Metals are elements whose atoms ionize by laws of electron. So now, without wasting our time, group 1, 2 elements and the transition elements are metals. So now, group 1 elements, group 2 elements, then the transition elements here, they are all metals. They ionize by losing electron, by loss of electron. And after they have lost the electron, they form positive ion. So you can see the only member of group 1 elements that is found in metal is hydrogen, like we have said before. So if you look at their configuration, they have valence electron of 1 or 2 or 3. So now, group 1, 2 transition elements and part of group 3 are metals. Now, what are the properties of metals? What are the properties of metals? Properties of metals. Number 1, this time around we are talking about physical properties. Physical properties of metals. Number 1, they are solid at room temperature. With the exception of mercury, which is what? Which is liquid at room temperature. So every other metals are solid. Have you seen iron? Iron, cutlass, is solid. Have you seen aluminium roofing sheet? Yeah, it's solid. So have you seen copper wire before? It's solid. So all these are metals. They are solid at room temperature. Number 2, the only metal that is liquid is what? Mercury. That is inside thermometer. That red thin line inside thermometer is what? Is mercury. Then number 2, they have high melting and boiling points. When we get to periodicity, we will tell us the reason why they have high melting and boiling point. What it means is that if you put a metal on fire, it takes high temperature of heat for it to change from solid to liquid. So you have to, the temperature must be very high. So the number 2, 3 thing is that they are ductile. They are ductile. What is ductility? Ductility is the ability of a metal to be what? Now, to be stretched into a thin wire. So you will see that's why we have copper wire, aluminium wire. They are stretched until they form thin wire. Now, they have high conductivity. That is the ability to conduct heat and electricity. So if you put copper inside electrical socket and you touch the other end, you will be electrocuted. So why are you electrocuted? Because they will conduct electric charge from one point of that wire to your hand. Then if you put iron spoon inside a hot soup, then you will see that it will be transferred from the bottom, from the mouth of that spoon to the handle. So they can conduct heat and electricity. So another thing is that they have high density. Density means what? Is the mass of a substance per unit volume. How heavy or how light something is. Iron is heavy, heavier than a plastic, heavier than a wood. So now iron is heavy, so they have high density. So another thing is that they have sonorous property. Sonorous property. What that means is that it means that they have sound property. Sound property. When you heat it, they give you sound. You heat iron, you heat to hear bang, 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 bang. Then another thing is that, number 7 point is that they have magnetic property, especially the transition elements. We have done that one in magnetic property under period. You can watch out for the video where we talk about paramagnetism, ferromagnetism, and diamagnetism. So check that. Then another thing is that they are malleable. They are malleable. What is malleability? Malleability is the ability of a metal. Ability of a metal to be beaten into thin sheets when red hot. When iron is red hot, the blacksmith, they will heat it until it forms flat body, which is a sheet. So their ability is called malleability. They are malleable. So another one is that they have luster property. Luster property. What does that mean? Now, that is, they have shiny surface when polished. When you polish it, when polished, it gives you shiny surface. So that is that. Now, so then let's look at non-metals. 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 These are elements whose atoms ionize by gain of electrons. What makes it so? Now, group 3 to O are non-metals. But mind you, some group 3 members like aluminium are still metals. So now, if you look at them, their configuration end in 3 or 4 or 5 or 6 or 7 or 8. So it is not difficult for them to lose these 4. Therefore, they will not think of, can I borrow 4 more to this one? Then you form negative ion C4 minus. This one borrows 3 electrons and add it to this 5. The sign of borrowing is what? Is minus. Then it forms negative ion, which is N3 minus. This oxygen borrows 2 electrons and add it to this 6. Now to now form 2 to 8 to 8. And it now forms what? O2 minus. which is a negative ion. Then fluorine now gains 1 electron to this 7 to become 2 to 8. Then it now becomes now from F minus because we borrow 1 electron. So they form negative ion when they borrow electrons. So that is that. Now, their properties in their own case, they are the opposite to those of metals. So that is, in their own case, they are not solid. Some of them are solid, like in the case of sulfur, phosphorus, carbon, they are solid. While others are liquid, like bromine. Then some are gases, like nitrogen, like oxygen, like hydrogen. So that is that. Then another thing you can talk about them is that these ones, metals have high melting point, but non-metals have low melting point. Then metals are ductile, non-metals are non-ductile. Metals have high conductivity, non-metals are insulators, they do not conduct electricity. The only exception to that is graphite, which is an allotrope of carbon that conducts electricity. Metals have high density, but they have low density. Metals have high sonorous property, but non-metals have no sonorous property. Metals have magnetic properties, but non-metals have no magnetic properties. Metals are malleable, but non-metals are non-malleable. Metals have high luster property, but non-metals do not have luster properties. So you can turn these ones upside down and form your note because of our time. Now let's look at metalloids. Metalloids or semi-metals. Metalloids are elements which share the properties of both metals and non-metals. They share the properties of both metals and non-metals. They form a borderline between metals and non-metals. In the periodic table. Examples are boron, silicon, and so on and so forth. You can see boron, silicon, they form border. They separate the non-metals from the metals. So those are metalloids. Now, let's now go and look at transition elements. Transition elements. Now, these are groupless elements which occupy the space between group 2 and group 3. Elements in the periodic table. They are groupless. They don't have any group. They do not belong to any group. Look at them here. No group name here. So they are found between group 2 and between group 3. Now there are two types of transition elements. Let's look at the two types of transition elements here. The two types of transition elements we have the inner transition elements and we have the first transition element. Now, there are two types of transition elements. Now, these are, first one, we have first transition elements, and number two, we have inner transition elements. We have first transition elements and we have the inner transition elements. And we want us to first of all talk about the inner transition element before we are going to spend time to talk about the first transition elements. What are the inner transition elements? Inner transition elements. First, the inner transition elements, what are they? Now, the inner transition elements are the period 6 and the period 7 transition elements. Period 6 and the period 7 transition elements. So those are the what? The inner transition elements. Now, what am I saying here is that I said these are the period 6 and period 7 transition elements. So they are F block elements. They are also called artificial elements. Why? Artificial elements, why? As they are mostly man-made. By radiations. So many of them are radioactive elements. They are made by radiation. Now, the period 6 transition elements are called lanthanide series. Why? As their first member is called lanthanum, La. So you can see it here. So it's not extracted out of this table. The first member is called lanthanum. That is why every other member here are called what? Lanthanide series. Then this is period what? Period 6. Why this one is period 7? So the period 7, transition series begin with elements called actinium, and as such they are all called actinide series. So that is AC. So the first member of this is actinium. So every other member here are called what? Actinide series. Now let's now move quickly to the first transition series. first transition series. First transition series. Now, this comprises scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. So what you have here, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. There are 10 of them. They are called the first transition series. Now, then this first transition series, they have some unique properties. Now, let's look at the first transition series have the following 4 exceptional properties. Which are not exhibited by group 1 and group 2 elements. And this is because of the presence of incompletely filled 3D orbitals in their atoms. What do I mean? Now, what am I saying? Don't forget, you have to look at what we have looked at before. You have transition elements, electron configuration, now the first one here, which is number 21, is scandium. Scandium 21. Don't forget, this is 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 4s2, 3d1. You can see that the 3d is supposed to carry 10 electrons, but it's only 1, so it is incompletely filled. It's not completely filled. So number 22, that's titanium. Titanium 22. That you have 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 4s2. Then this one ends in 2. So 3d is supposed to take 10, but it's 2 that is there. So that 3d is incompletely filled. Now number 23, you have vanadium 23. So you have 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 3, 4s2. You can see that the 3d that is filled glass can take 10, but it's 3 that is there. So 24, you have chromium. Chromium 24. Don't forget that one is 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 5, 4s1. I hope you know why. You can visit electronic configuration, the video we had before, and see why it ends in 4s1 and double fill 3d here. So if you continue like that, you get to zinc. You will see that, okay, it is only now only 29, which is copper 29, and zinc 30, zinc 30. Now copper 29 has 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1. Then zinc is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2. So you can see that zinc is what? Is fully filled, but there's some implication to that. I'm going to show you a question as we continue. Now, what am I trying to tell you here is that I'm telling you here that transitional elements have 4 exceptional properties that group 1 elements and group 2 elements do not have. And the reason for that is that they have incompletely filled 3D. Exceptionally, zinc is the only one that has, and copper that have completely filled 3D. So what are those exceptional properties? Exceptional properties of first transition series. Number 1, they form color compound. They form colored, I will show you the practical of this one, colored compounds. Don't worry, I'll show you that. Then 2, they form complex ion. They form complex ion, don't worry, we'll talk about that. Then they have variable oxidation states. I will see explain this one by one. Now, then the next thing is that they have number 4 now. Number 4, they have catalytic property. So they are used as catalysts, either as elements that they are, or as part of a compound. So let us look at what we are talking about: formation of colored ions, colored compounds. I want to show you some things here. Ions, then color. Now we have copper 2 ion. Copper 2 ion. The color of copper 2 ion is what? Is blue. Pale blue. I will show you. Then we have copper 1 ion. Copper 1 ion is reddish brown. Reddish brown. Then we have Fe2+, that is ion 2 ion. Ion 2 ion is green. It's green, I will show you. Then we have Fe3+, which is ion 3 ion. Ion 3 ion is brownish yellow. Brownish yellow. That is rust. You have seen rust before. If ion gets rust, so that is that. Then you have chromate 3 ion. Chromate 3. Chromate 3 ion. Its color is green. Then you have chromate 6 ion. Chromate 6 ion. Chromate 6 ion. The color of chromate 6 ion is orange. Orange color. Orange color. Orange color. Then we have manganese. We have Mn2+. That's manganese. Manganese 2 ion. So the color of this one is pale pink. pale pink or colorless. Pale pink or colorless. Then we still have Mn7 plus. This is manganese 7 ion. Manganese 7 ion. So this one is purple. This one is purple. So that is that. They have color property. Let me show you that. Let me show you some of the ones I can show you here. Now, okay, this is iron 2 tetraoxosulfate 6. That is FeSO4. Let me see. Put it in a boiling tube and tell me the color of this. Now you can see. Now let me try to add sodium hydroxide, and you now tell me to give me dirty green gelatinous precipitate. Dirty green gelatinous precipitate. So now let me add sodium hydroxide. You can see what I'm doing here. So let me try to add. Can you see? This is dirty green. That dirty green gelatinous precipitate you are seeing there is iron 2 hydroxide. So the color of iron 2 hydroxide is what? Dirty green gelatinous precipitate. So that is that about that. Now, then let me show you copper 2 ion. So this is copper 2 tetraoxosulfate 6. Can you tell me the color of what we are seeing here? This is pale blue solution. Can you see? This is copper 2. So the presence of copper 2 ion makes this solution a blue solution. Copper 2 solution is a pale blue solution. If I want to, this is a clear solution now. It dissolves totally in this water. So if I am going to pour sodium hydroxide inside this solution, it gives me pale blue precipitate of copper 2 hydroxide by double decomposition. So you can see what I'm talking about here. So if I pour sodium hydroxide, you will see that some particles of blue particles will come out. Wash. Can you see? Can you see? Can you see what I'm talking about here? Pale blue precipitate. You can see precipitate gelatinous. It's even dirtying the body, making sticky, getting stuck to the body of the boiling tube. So that is that. Now, so without wasting our time, so what we have there is iron 2 ion. Copper 2 ion. You can see this is reddish brown in color. Copper 2 ion is here. So that is that. Now, without the waste of time, let me just jump here. They have variable oscillation states. Group 1 elements do not have variable oscillation state. One element has more than one. Look at copper. Copper and copper. You have copper 2 carrying 2 plus. You have copper 1 carrying 1 plus. Variable. More than one type of oscillation state. So that is one of the things they do. Then you have iron 2 ion and iron 3 ion, the same element. One carries 2 plus, the other one carries 3 plus. Then you have chromate 3, you have chromate 6. Chromate have 2 variable oscillation states, 2 different oscillation states. You have manganese 2 ion and manganese 7 ion, have different oscillation states. You can see that. So then the next one is that they form complex ion. They form complex ion. So what am I talking about here? Now, what is complex ion? What is complex ion? What is a complex ion? They form complex ion. Now, what are complex ions? What is a complex ion? A complex ion is an ion formed due to coordinate covalent combination of a centrally located transition element, elements, ion, and a number of charged group called ligands. A number of charged group called ligand. What are examples? Examples are, number one, we have tetraamine copper 2 ion. Tetraamine copper 2 ion, which is the same thing as Cu. NH3 is the amine, or 4 of them, then copper 2 ion. So this 4 amine is a ligand. There are 4 ligands now, forming coordinate covalent bond with copper 2 ion. In the next class, we are going to look at chemical bonds. Then you are going to know much about this. Then another example, you have diamine silver 1 ion. Diamine silver 1 ion. That is Ag. You have NH3 2. Then you have plus. So you have 2 ligands here associated with silver. So silver is a transition element. Another example, you have hydrated copper 2. We have hydrated copper 2 ion. So that one is, you have Cu H2O, then 4 of them, then you have this block bracket 2 plus. That's hydrated copper 2 ion. Which other examples do you have which are complex ions? Now, other examples, you have number what now? You have number 4 example, you have hexacyanoferrate 2 ion. And the formula is going to be ferrate Fe, hexacyano is this hexa. Then you have 4 minus hexacyanoferrate 2 ion. This is it. Then you have hexacyanoferrate 3 ion. So that one is FeCN6. Then you have power of what? 3 minus. You have as many. You have number 6. You have tetrahydrozozincate 3 ion, and so on and so forth. So you have ZnOH4 zincate 3. So you have tetrahydroxoaluminate 3, and so on and so forth. So in another class, we will talk about complex ion when we get to coordinate covalent bonding. So, and lastly, we have said that they have catalytic properties. So you will see that some transition elements like are used by themselves for catalytic process. For example, vanadium 5 oxide. Vanadium 5 oxide is used in contact process for the oxidation of sulfur 4 oxide to sulfur 6 oxide. Then manganese 4 oxide MnO2 is used during Haber process. Is used during thermal decomposition of potassium thiazochlorate 5 and thermal decomposition of hydrogen peroxide to release oxygen. Then we have finely divided ion used in Haber process in the production of ammonia from its constituent elements, which are nitrogen and hydrogen. So you can see by themselves or in combination with other elements, they are used in making catalysts to suppress the activation energy of a reaction pathway. So when we get here, we are going to talk about that. So I've seen some questions before. What are those questions? Let me just discuss those questions with us, then we will call it a day. That question here is that they will say, in our evaluation class now, evaluation. They say, now, they say, which of the following elements, which of the following transition elements does not have color property? And state one reason for your answer. Answer here is zinc. Zinc 30 and scandium 3 ion. How? Why? Now, how did I know? Write the electronic configuration here: 1s2, 2s2, 2 pieces, 3s2, 3 pieces, 3d10, 4s2. Then this one is 1s2, 2s2, 2 pieces, 3s2, 3 pieces. Then you have, without the charge, you have 3d1, 4s2. So if it must carry 3 plus, what happens? Then this 4s carrying 2, 2 plus 1, this one will go. You now add this. So now, answer is what? Answer, it can be what? Zinc, neutral zinc, and scandium 3 ion. Why? Lack reason. They lack incompletely filled 3d orbitals. So you can see that the 3d in zinc is completely filled, 3d10, and this one does not even have it at all. So that's why when you see zinc 2 salts, they are colorless. They are not like copper 2 ion, which is what? Which is bluish in color. Copper 1 is blue, copper 2 is blue. Why is copper 2? Some people say, but copper 2 is what? Copper 2 Cu2 plus. When it is neutral, 29, it will be 1s2, 2s2, 2 pieces, 3s2, 3 pieces, 3d10, 4s1. So for it to form copper 2 ion, so this one will go carry 1, and one of these 10 will not be 3d9. So then the 3d is what? Incompletely filled. That is why copper 2 ion is what? Is bluish in color. Then copper 1 ion, if the 4s1 goes, so then it will be reddish brown. So we are stopping this lecture here. So we create room. After this, in the next lecture now, I will bring out some JAMB and WAEC questions to test our knowledge about electronic configuration and periodic table part 1. In the next class, we are going to talk about periodicity. That is part 2 of periodic table, where we are going to be talking about activation energy, electron affinity, electronic and thermal conductivity, boiling point and melting point, and their variations across period and down the group of elements in the periodic table. I remember myself after Ademola Johnson. Please do try to subscribe. Try to subscribe in my YouTube channel, Afe Ademola Johnson, and you try to share this video and like it. See you in our next class. God bless you. God bless you, and bye for now. Thank you.